As I mentioned in part one of this series, the first podcast as well, this is number two, we would spend a few minutes going through basically where to get this emissions information. So when we start tying things in on the electrical side in particular, we'll get into some of the other stuff later on and some of the tools for those. But for now, we're talking about electrical things and how it ties back into tools such as electrical signature analysis and identifying the losses associated with a defect, right? So if I say have to replace a bearing, or I have to improve an alignment, or just greasing, gearbox oil, belt tensioning, any number of other things, up to and including my power quality issues, I'm going to be able to trace this back to an energy impact, right? And then I can take that energy impact and tie it in directly to emissions, especially if my company has a goal. So some of the tools we're going to end up using include eGrid, which is US EPA. Now, what's important about eGrid is it's going to allow us to take a look at data based upon our region and some other stuff. There's two types of energy we have to be concerned about, and I'm just going to make this really simple. I'm not going to go off of their classifications, but one has to do with when you're putting together an inventory of the greenhouse gas emissions for your facility for reporting purposes or whatever you're doing. That's one method, and then the other method or the other classification has to do with energy avoidance or emissions avoidance, and that is where we reside in reliability and maintenance. So if we do an activity that reduces energy consumption, that comes off of what's called the variable load portion of the grid. So that is looked at actually to our benefit when we're reporting values. So the national average for that is about 0.709 tons, metric tons, that's 2,240 pounds to metric ton of CO2 per megawatt hour of energy usage. Okay, so we're always going to talk in terms of megawatt hours or kilowatt hours. Now, most of the US EPA work uses pounds per megawatt hour, kilowatt hour. I would recommend converting that to tons because the numbers seem more realistic or will appear more realistic to management. If you go in saying we're reducing 1 million pounds by improving a bearing, that's not going to sound as good as, hey, we're going to reduce 10, 15 tons of CO2 by taking care of this particular electric machinery issue. So with eGrid, here we have all of the different information that's readily available. So if I were to go in here and I wanted to see my emissions, I would click on this, and this would actually take me over to Data Explorer. And in Data Explorer, I can look at different regions and so on. So let's say because I'm here, so the CO2 total output emission rate, that means the total production related emissions. This is not the value we're going to use, is 1,046 pounds per megawatt hour, or about 0.45 roughly metric tons of CO2 per megawatt hour. That would cover the region I'm in the Midwest, primarily because there's a lot of nuclear power in here, a lot of clean energy, so those numbers are going to vary. If I go down to ERCOT, and we've all heard of ERCOT, that's Texas, that's 813 pounds. So this would be the value we would be using for our inventories on the electrical side. So that is somewhere around 0.3. Now their actual avoidance is going to be much higher. So if we go in and we take a look at what's called AVERT, okay, so www.epa.gov/AVERT, and I'm going to have these links in the discussion page. for this. This is where we can go and we can get all of our other information. We can run calculations online. You can download the database in Excel, and that can also break it down by region as well. From here, there is another neat little ability built in where you can actually look and see what the health risk impacts are on the emissions. Now, this will take into account more than just CO2. It takes into account other things. So this is health and safety. And then finally, the equivalency. So when we're going through and I say, okay, we're just going to use national average numbers for the project we're doing. We're going to say, okay, we're going to have avoided. Now, if I use used, I'm going to use a different value. So I'm going to show you what that looks like. So if I say, okay, let's go with 1,000 kilowatt hours avoided. I convert that data. It's going to do a couple of things. Here's my 0.709 metric tons of CO2 per thousand or per megawatt hour. Okay. And then here are equivalencies of what that's done for us. So if I just reduce by 1,000 and I reduce it by 0.709 metric tons, that reduces 1,800 miles of a gasoline car, 80 gallons of gasoline, things like that. These are things that I can use to show the impact. Now let's go ahead and say, okay, let's say consumption. This would be more along the lines of what we would be doing in megawatt hours for looking at our inventory of CO2. So if I say inventory is 1,000 kilowatt hours, and believe me, if we're on here, it's far more than that. That would be 0.433. That is a completely different number. This is what we use for doing the inventories. This includes all power generation, including the base generation, whereas avoidance, which we use for maintenance practices, here we go, choose this one. Oh, there, the explanation. When entering data on electricity use avoided through energy efficiency or some other generation avoided through renewable energy, note the calculator used national averages and use the AVERT or eGrid. For the used, this would be when entering data on electric use, such as your household or company's annual electrical consumption for inventory purposes. So that gives me a much different value. So we'll be staying in this area here. You can see, of course, there's other information for natural gas for when we do some other things. But anyways, that was a quick introduction. We will use these as we go through some of the activities moving forward in this podcast. We're going to talk about things such as greasing bearings, bearing defects, belt tensioning, and so on. And we'll take that information, look at the energy consumed, how that's avoided before and after, take the difference, and then put it into these calculators in order to show you how you can report this back. Now, it's very important to understand that it's not necessarily the identification of actual defects, but it could also be improvements, such as making improvements on your precision. So if I'm doing a precision maintenance program, say I do a precision alignment, I can take a look at my losses associated with the alignment ahead of time using a tool like Empath. Of course, I'm going to mention Empath for ESA, in which we can identify the defects by each defect I can relate directly to energy impact. Then I can take that information and put it in here. So going from a misalignment, which may be costing me, say, let's do an example, say, and using a national average, say it's a kilowatt loss, and I'm running 8,000 hours. That's 8,000 kilowatt hours. So 8,000. so 8 megawatt hours. Convert the data. That is, got to go by avoided, see, 8,000, that is 5.7 metric tons, just for a slight misalignment, 5.7 metric tons of carbon dioxide avoided. And there's other information I can go in to identify instead of just CO2, but everybody's going off CO2. That is the removal of 1.5 gas-powered vehicles per year, or the equivalent of 638 gallons of gasoline consumed. That's a lot of mileage. Trust me, I don't use that on any of my 1,400 mile trips. Or 6,400 pounds of coal burned, etc., etc., etc. All of this stuff I can use to report back, and this is stuff that I can report to management that will make its way to the sea level. With that, I will say thank you very much. Next week we will cover a simple one, and that will be a belted application and how that ties back in. And then we'll see the energy, we'll see the emissions, and take that up to the corporate level.